guys, welcome back to my YouTube channel. So today we are going to solve day 1 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 1497. Check if array pairs are divisible by k. We have given an array of integers of even length n and an integer k. Okay, so we have given an array of integers of even length and k value, right? We want to divide the array into exactly n divided by 2 pairs such that the sum of each pair is divisible by k. Okay, we have to return true if you can find a way to do that, or false otherwise. Okay, so see here example number 1. So first, what is the count of this array length? So 1 2 3 4 5 6 7 8 9 10. Okay, so length of this array is 10. So we are looking for total 5 pairs, right? 1 2 3 4 5. Okay, we want to divide the array into exactly n divided by 2 pairs, 5 pairs, such that the sum of each pair is divisible by k. Okay, so here what is the sum of this pair? 10. Okay, and 10 is divisible by 5. What is the sum of this pair? It's also 10. It is divisible by 5. Sum of this pair is also 10. It is divisible by 5. Sum of this pair is also 10 and it is divisible by 5. Sum of this pair is 15, right? And this is also divisible by 5. Okay, so all these pairs are divisible by 5. So that is why we are returning true here. Okay, and see here total length is 6. So these are the pairs 1 6 2 5 and 3 4. So here sum is 7. Here sum of these two numbers is 7. Here sum of these two numbers is 7, right? And hence all these 7s are divisible by 7, so we are returning true, right? And here see this example. So length is 6, but you can try all possible pairs to see that there is no way to divide array into 3 pairs each with sum divisible by 10. Okay, so there is no possibility, so that is why we are returning false. And these are the constants given to us. Okay, so now let's see how we are going to solve this problem. Okay, so simple. Now we have to find the pairs and see if these pairs are divisible by 5, and if this is true, then we are just going to return true if this is possible for all the numbers in this particular array. Okay, for all the pairs n divided by 2 pairs. But if it is not possible, then return false. Okay, so brute force is not going to be helpful for this one, right? Constants are very large. You can't just first take this number and try to make a pair of this one with all the numbers, and take another number, then do the pair with the whole number. This is a very long process. Okay, we can't do this. Brute force is not helpful for this. So now how we are going to solve this problem? Okay, so first thing here, I'm going to use this expression in my coding. Num, okay, particular number modulus with k plus k modulus with k. So why I'm going to use this? So it is a way to ensure that remainder from the modulo operation is always non-negative, even for negative numbers. Here is a breakdown. Okay, so see here, when you use num modulus with k, the result is the remainder of the division of num by k. For positive integers, num modulus with k always give a straightforward remainder that is in the range 0 to k minus 1, right? And for negative numbers, it is going to give the negative number. So here when num is negative, okay, and you do this num modulus with k, it can produce a negative remainder, right? So here minus 3, and you just divide it with 5. Okay, so it is going to give you the minus 3 as a remainder. Okay, minus 3 mod 5 is minus 3. This negative remainder is not useful when you want to group numbers based on their remainders. Okay, so we have to group the numbers based on their remainders, right? So what we are going to do, we are going to add k. Okay, by adding k to the result of num modulus with k, we shift the negative remainder into the positive range. Continuing the previous example, minus 3 mod 5 plus 5, so I will get 2. Then again take the modulo. Finally applying modulo k again ensures that the result is within the desired range 0 to k minus 1. 2 mod 5 is 2. Okay, thus if the initial result was negative, this adjustment brings it back to a valid remainder, right? So here minus 3. Okay, so you see this example, so this is what we are going to use, right? So minus 3, and let's say there is one number 3, right? So here if I just do this with 5, okay, I find the remainder, I will get the remainder as -3 here, and here I will get the remainder as 3, right? So I will change this -3 to 2 later on by using this formula, okay, -3 to 2, okay, because I need the numbers in the range 0 to k minus 1, right? I need the numbers in this range, okay. So later on, if you just do this summation 3 plus 2, you will get 5, okay. So just make the pair of these two, -3 and 3, so you will get 2 plus 3 total 5, and 5 is completely divisible by 5, okay. So it is also going to make one pair now. -3 and this 3 are one pair, right? If my k is 5, so they are one pair, right? But if I just take the -3 remainder, then it is not going to be helpful. I need here, instead of this -3, I can write 2 and 3. Now see, 2 plus 3 is 5, 5 modulus with 5, 5 is completely divisible by 5, right? This is what we need to do, and these are the pair definitely, -3 and 3, 0, right? So that's why we are going to do this adjustment here, okay. So this is done. Then after that, how we are going to solve this problem? So first we are going to initialize the remainder count. So we are going to create an array remainder count of size k, which is 5 in this case, okay. So we are just going to pick one example, okay, to keep track of how many times each remainder appears when element of array are divided by k, okay. So let's I'm picking this example number 1, okay. So first element is 1 2 1 2 3 4 5, then 10 6 7 8 9, okay, and k is 5, okay. Now see this. So take this remainder count array, okay, of size k, okay. So initially all these values are 0. Then we are going to count the remainders. So for 1, so 1 modulus with 5, I will get output as 1. So here I'm just going to update a remainder count of this 1, okay, remainder count of 1, this one, whatever one I am getting here, okay, remainder count of 1, it is increased to 1 here. So 2 mod 5, I will get this 2. So remainder count of 2 is incremented to 1. For 3, when number is 3, so I will get 3. So remainder count of this 3 is incremented, I will get 1 here. A remainder count 4, okay, 4 comes, so 4 I'm getting, so here I have incremented the count of this one, okay. Now 5 comes, so 5 mod 5 is 0, so remainder count of 0 is incremented here 1. Then 10 mod 5 is also 0 now, so here again I have incremented the count, okay. So see this, 5 and 10 are making one pair, right? Both are having 0 remainder, both are having 0 remainder, both are making one pair, okay. Now see here, 4 6, 6 mod 5 is 1, okay. So increment the count of this one, so 1 plus plus, so here see this is 2, okay, this is incremented to 2, okay, 1, this one, okay, 4 1 and 6, okay. So here I have incremented this. Then 4 7, 7 mod 5, so we get 2, for 2 I have incremented this count, for 3 I have incremented this count, for 9 mod 5, okay, this number comes, then I have incremented this count, okay. So I told you guys that this is going to make one pair, okay, this 5 and 10, okay, these are making one pair, 5 and 10, okay. So but others we are going to check like this. So here and here, this one, okay. So this one index is matching with this 4, right? So here just see here where we are getting the remainder as 1. We are getting the remainder as 1 in here 6, and 4 1 we are getting, okay. And where are we getting the remainder as 4? We are getting remainder as 4 as at this 9, okay. And we are getting this remainder 4 here at 4, okay. So see, both make a pair of both these, okay, 6 and 4 and 1 and 9. So 6 4 10, 10 is completely divisible by 5, 1 and 9 is 10, 10 is completely divisible by 5, okay. 6 4 and 1 9, 6 4 and 1 9, okay. Same way you will get 2 8 and 3 7, okay. So check for this one, okay. So just for this one we are checking with this itself, but for others I am checking with this one and k minus 1, okay. 1 again k minus 1, okay, 5 minus 1 4, okay. So see how this is working actually. So at the end of this step, remainder count looks like this, okay. Now we are going to just check for the pairs. So now we check for the pairs for each I from 1 to k minus 1. So for 1, remainder count of 1 2, and remainder count of 4 2, okay, both are matching, so we are getting true. I is equal to 2, so remainder count of 2 is 2 and remainder count of 3 is also 2. Both are matching, so we are returning true. Since all the pairs match, we proceed to next step. Special case. For remainder 0, we check if the count of elements that give a remainder of 0 is even. Okay, so this is going to be one special case. So this is true, then this is valid. Okay, so in the end we are just going to return true. Okay, so now why we are pairing the remainders? Okay, we are just pairing the remainders now. So here I am getting the remainders as 2, remainder as 2. Okay, so why we are doing it? So when you want two numbers a and b to have a sum that is divisible by k, the function must hold true. A plus b mod k should is equal to 0. Okay, this must be true. Now this can be broken down in terms of remainders. Let Ra be the remainder of a when divided by k. Okay, R is the remainder of a when divided by k, and Rb is be the remainder of b when divided by k. Okay, Rb is the remainder of this b divided by k. Okay, so for the sum a plus b mod k to equal to 0, we need this Ra plus Rb mod k equal should be 0, right? This means that Ra Rb should be either 0 or k. So this is working na 0 or k. This is what we need. So see here, example number 1. See here. So here what is the remainder that we are getting? So okay, you can see this now. I have given the example here itself, I think. Yeah. So see here. For the given remainder Ra, this complementary remainder that pairs with it to achieve a divisibility by k is Rb is equal to k minus Ra. Okay. See all these pairs. So we are making the pair of 0 by 0 itself, right? So that is why this condition is going to satisfy. Elements with the remainder 0 can pair with each other. So this is true now. This is true. We see this. Remainder 0 can pair with itself. Okay. This is done. Then 1 and 4 are pairing. Na? Elements with the remainder 1 can pair with the elements with the remainder 4. Since 1, 4 summation is 5. Right? Elements with the remainder 2 can pair with the elements with the remainder 3. Since 2 plus 3 is equal to 5. Okay. So that's why this line is working. And that's why you see this example here. So this 4. Okay. This 4 is pairing with 1 and 1. Okay. K value, total k value 5, right? So that is why we are pairing 9 with this 1 and this 4 with this 6. Okay, same way this 2 is going to pair with this 3. Okay, so this 2 is going to pair with this 3. Okay, 7 and 8 and 2 and 3 can also make one pair. 8, 7, 15 and 3, 2, 5 all are divisible by 5, right? And here see their remainder summation is also equal to 5. Okay, so that's why we are doing this. Okay, so I hope that this is clear. So the check if remainder count of I is not equal to remainder of count ensures that for every remainder I from 1 to k minus 1, the number of elements yielding from the remainder must match the number of elements yielding from its complementary remainder k minus I. If they do not match, it means that there are unmatched elements and thus it is impossible to pair them in a way that satisfies the divisibility condition. Okay, so let's take this example here one more time. K is equal to 5 and here is an example with the remainder. So we are getting the remainders as 2 to 2. So here we see remainder 1 and 4 are matching, right? And 2 and 3 are matching, so they match. Okay, and this is also matching with itself. If however you had a remainder of count 1 is 3, okay, let's say this is 3 and the remainder count of this 4 is 2. Okay, then the check would fail. Why? There would be 3 elements with the remainder 1 but only 2 elements with the remainder 4. Then how can you make the pairs? Okay, thus you could not form pairs for all elements, leading to a return of false. Okay, so that's it. So I hope that you guys are clear with this explanation. Now we are going to move to the coding part. Okay, so let me just increase the size here. Okay, and now first thing that we need to do here, let's first create the remainder count array. Okay, so here write int remainder count array, new int and size, let's say give k. Okay, k is going to size. Then we have to count the frequency of each remainder. So let's use this for each loop, int num, and we are going to iterate over my array elements one by one, and inside this I'm just going to take the remainder. Int remainder, okay, is equal to, so here I'm just going to use that simple formula that I have explained, num modulus with k. Okay, if number is negative then just do this k, add k, and just take the modulus with k again. Okay, so this is the thing that I've explained previously, right? So this is going to ensure that the remainder is non-negative, right? And then after that for this remainder we have to increment the count now. So here in this RC, just pass this remainder and increment it. Okay, this is done. Then after that we are going to check for the pairs. Okay, so for int I is equal to 1, I is less than k, and here I plus plus. Okay, and inside this I am just going to check if remainder count of I, okay, is not equal to remainder count of k minus I. Okay, and in that case we have to just simply return false. That's it. Okay, and once this is done, then we have to check for the special case for the remainder 0. Okay, so if my remainder count at this 0 modulus with the 2, okay, I have to just check if it is even. Okay, and here is not equal to 0. Okay, and just change this. Okay, if remainder count of 0 modulus with 2 is not equal to 0, then in that case also just simply return false. Return false. Okay, so we can't pair up all the 0 remainders, right, if it is not even. Okay, and in the end just return true. That's it. Code is very easy, right? Now let's run it and see if there are any code issues. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And the time complexity here, it is running for all the elements of my num array, so n, and here it is running for k, okay, O of n plus O of k. O of k is nothing but the O of n plus O of k, and yeah, that's it. So you can see the time complexity from here. O of n. Okay, so k is going to be smaller than this n, so you can just say time complexity is O of n for this one. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.